Okay, this is working. Hi, everybody. How are you doing today? Okay, I got some grumbles, so I guess that's all I can expect. It's fine. So I'm going to be talking about performance. Oftentimes we hear people say, make something people love. But this isn't one of those talks. I'm going to be talking about making something that people don't hate, which, in my opinion, is a little bit more important. So I'm going to be talking about cake, because I don't think many people hate cake, and also it goes well with tea. You know, I heard that y'all like tea around here, so it's fine. So this cake is going to be our product. It's a metaphor for how performance is really a team effort. And it takes a lot of different specialized roles. It's a huge task that I can't even begin to cover, but I'm going to try. So performance, as dictionary.com defines it, is an action, task, or operations in terms of how successfully it was performed, which is pretty much the crux of our job. You know, we want to be successful. So performance is our biggest job. And as lead developers, it's also your job to make sure that everybody is on the same page. So that's why I'm going to be talking about performance in terms of an entire team and across the whole spectrum. So beautiful does not always mean usable, and in fact, usable is much more important than an app or a website being beautiful. Because if somebody can't access your content, then what's the point of putting it out there in the first place, right? So when you find that niche between beautiful and usable, you get this delightful experience that everyone loves to talk about and is aspiring to. So I want to talk about performance-first design from the beginning of the process. And I won't bore you with a lot of these facts, but this is a pretty good one. So Google calculated that slowing its search results down by just 0.4 of a second lost them 8 million searches per day. That's a lot of missed ads and revenue. If you look at those numbers, so if you have 8 million searches, it's a daily loss of $111,000 a day, or $40.5 million a year. I can't even fathom that number. It's huge. So pretty much we're just doing this. If you don't care about performance, and I'm sure that you're going to love that for your team. Here's another fact. 100% of users have felt frustrated by poor performance. This isn't a real fact, but it's true. We all know this too well. We don't want to do this. So a really great article that I read was by Tammy Everts, and it was talking about how performance is about neuroscience. It's not even about our entitlement. It comes down to two phenomenons, really, and that is web stress and the doorway effect. So web stress is a physically measurable increased agitation response to slow websites. And it's caused because we as humans are just bad at remembering things. The doorway effect sort of explains why we can go searching for something. So say I'm looking for my keys before I leave the door. Maybe they're in the kitchen, but I walk over into the living room looking for my keys. And then as soon as I step into the living room, my reaction is, what was I looking for in the first place? It's because the entire environment changes around you. So we forget because we have these new things coming at us. And it happens because of our sensory memory, which actually works surprisingly similarly to a computer's memory bank. And the sensory memory comprises of all of our senses. We don't control it, and it lasts for a very limited amount of time, but it allows for fluid continuation of a task. So iconic memory helps us visualize that time bank. If I had a rope, and I was spinning that rope, if I'm spinning it faster than my iconic memory bank allows for, then you see a fluid circle. You see that rope looking like a full circle. So that's faster than 100 milliseconds. But if I spin it slower than that, then you see a gap. So you see that sensory memory gap in the rope. And it's really great because iconic memory allows us to visualize and understand how this works. But on the web, every single tab that you open is like walking into a new room. And there are so many distractors that people will just completely forget what the task that they had on hand was. And that's why performance becomes increasingly important on the web. So the first thing I'm going to talk about is sort of the UX architecture, and this is the base upon which the cake stands. It's the core of the product. It's what people really use and interact with. So that's the content strategy. It's the ingredients. It's what you put into your cake. You probably wouldn't mix onion powder and lime juice and chocolate. Maybe, I probably wouldn't. So you really need to think about this. Content is honestly king. It's the main point of your site. And no matter what I tell you in this presentation, if you don't optimize the content that you're putting into your application, then nothing else is really going to matter. And it's because charts like this. So this shows us the increasing size of websites over time. It's a really excellent graphic. But what you see here is images are red right up top, way above any scripts or even flashes in there, HTML style sheets, etc. And all these things in the bottom are things that we are constantly talking about optimizing for. But images are going to make a huge impact. So people talk about not including jQuery, but jQuery minified is 86 kilobytes. If you got rid of 1/5 of the average image size on the web, which is 654 kilobytes, then you could have as much jQuery as you want. Just 1/5 of one image. So in about 5 months, the average web page size will be the same as the Doom install image. So way to go, us. You have to ask yourself, do I really need that? What's the main goal here? And what's next? What do I want the user to do next? So for us, what's next is UI design. And that's sort of the visual representation of your masterpiece here. This awesome Lego cake is that representation for us. And it kind of describes how you need to really understand your craft. So that includes the types of files you're using, the ingredients that you're putting in, how you're making design decisions, and how that impacts performance. So image file types are really important to know. So JPEGs are raster lossy format, and they're really good for images with a lot of color. And these sort of depend on the pixels per inch of your device screen. Then we have the PNG, which really excels when the image has large, uniformly colored spots. So even sometimes photographs are better as PNG images. And they have two types. There's a palette variant, which has 256 colors, and that's called a PNG 8. So because of the limited color range, there may be artifacts on this. There are a couple of artifacts on the outside. But there's also the PNG 24, which is sort of the true color variant. They are a little bit bigger, but you won't have the same artifacts that you have in the PNG 8. There's also GIFs, which aren't always animated, but this is a lossless, limited color range like PNG 8, but usually a JPEG is a better choice. Fun fact, the PNG came out as an open source reaction to GIF threatening to license, so I'm a big PNG fan. And then, of course, there's SVG graphics, which are vector graphics, and you can export those from Sketch or Illustrator, and they don't matter the size of your PPI displays. It really depends on the situation. So here we have an image of a paint can. You see the GIF is 11.7 kilobytes. The 8-bit PNG is 6.39 kilobytes, and the JPEG is bigger than both of those at 19.3 kilobytes. And in this case, you can see, because it has those large blocks of limited color, that a PNG is optimal choice. And you can make these choices when you do Save for Web inside of Photoshop. You have all of these optimization properties. It even shows you what the size is, and you can really play around and fix things. So one of my favorite quotes about this is, never put an image on the web that you have not optimized, by Dave Rupert. And you could put this in your team charters. I think this is a great rule to include in them. There are a lot of compression tools for us to do that with. So image alpha is a way of reducing colors in a PNG 24. So you get a toolbar that you can manage and sort of really customize it. Tiny PNG is a tool you can integrate into your build tools. There's a few of these. So Image Optim is another great tool. This is automatic. You can just drag and drop an entire folder of images and watch as the image file size trickle down. There is Compressor.io, which is a web version, and that also handles a few different image types. And then SVGO, or SVG Optimizer. The one that I like to use is ImageMin, because it has GIFsicle, JPEG, Tran, OptiPing, SVGO. It uses a lot of those different compression algorithms to just really quickly, without me thinking about it, make things happen and make my images as small as possible just through gulp. It's just one of my build tools. Another idea that you can do is using compressive images. And what compressive images allow us to do is save a JPEG image at double its size, but at 0% its quality, and allow the browser itself to scale it to fit into a smaller placeholder. And you can reduce the image weight while increasing the bit depth so it looks the same. Here we have our buddy. And this image is 109 kilobytes, so I'm gonna save it at quality of 0, but at a size of 200%, and now he's 49 kilobytes. But he looks the same. You would never know. So that's a pretty cool trick that you can use. Progressive JPEGs are another tool that you can use to sort of decrease load time perceived performance of your products. So there are two types of JPEG images. There's baseline and progressive. And progressive JPEGs used to be the standard, but they've no longer become the default. What they allow you to do is take scans of the image. So they're a tiny bit bigger, about 2 kilobytes in this case. And it is instead of really big performance win, because instead of waiting for the image to sort of load from the top down, you get these scans. So it's blurry and then it becomes clearer and clearer and clearer. That's something that you can just check off when you save JPEGs. So like I said, they're a tiny bit bigger, but they appear faster, so it's a big win. It's about how the page feels. And that's when I'm going to talk about Retina images. So Retina images sort of come back to the content strategy side of things. You have to think, do I really need that? They look nice on screens, but those are really terrible for your users, and data plans aren't cheap. I don't have a data plan here. It's been tough. So if you don't use Retina images, it'll really decrease your download size of your images. And what we're really aiming for here is less than 1 megabyte, including all of your scripts and images for when you have your initial download of your files on your site. So think, do I really need that? If you really need that, there's Picture Fill, which is created by Filament Group and Buku. Scott Jello did a lot of work with this one, and it allows you to serve images based on sort of a variety of conditions, like screen size, viewport size, and screen resolution. And you can decide. You can even go and figure out how much your site costs if you're doing this, and you'll probably be surprised. WhatDoesMySiteCost.com is a great tool and resource for seeing the impact that we're making on other users. So don't be selfish, because we have really fast internet and really nice MacBook Pros. Jank is the next thing I'm going to talk about, and this is probably my favorite term in all of web development right now. And I'm going to talk about this magic number that everyone likes to reference, which is 60 frames per second. Jank is that sort of slow, crappy experience we see on the web when things are just moving around. And it causes frustration a lot of the time, but 60 frames per second is sort of the frame per second rate that the human eye doesn't see any glitches or changes. But keep in mind that it's always going to be different on desktop than mobile, so you definitely want to start testing things. What you can do to test it is in the timeline panel of Chrome, there's a little record button. You can hit the record button, do a change on your page, so whatever animation you want to change, you try to make that recording as limited as possible, and then you get a screen like this. So here we can see 30 frames per second at the top bar and 60 FPS at the bottom bar. And we don't want to exceed that 60 FPS bar. So the higher it is, that's a slow interaction, something that was janky on that site. We don't want those spikes, so try to keep it below that. You can also, inside of the console, there is a little button for show FPS meter and also show paint rectangles. So you can just scroll along your website, and then in the top right-hand corner, it shows you the frames per second live as you scroll, and your GPU memory, what you're using up. There's an excellent website called Css Triggers that kind of shows you what exactly you're doing when you change CSS properties inside of your app or your page. So this is sort of the browser trying to figure out what everything lies in the page. So it does a bunch of geometric information calculating. And then when you change that, it has to recalculate the page. So what you can do to avoid or limit this is only change your transform properties or your opacity. And this allows for GPU acceleration on the page to occur instead of the CPU working to make those changes on the site. And it creates for a smoother transition. You can also use a hack called the Translate 3D hack, where you just do Translate 3D 0, and it also forces that GPU acceleration. But don't overdo this, because again, if you do overdo it, it might appear faster, but it will kill battery life, and it'll cause your user that stress. It's not you, it's all on your user. Another fun fact that I found out is that Flexbox is actually a lot better performance-wise than older layout models. And Paul Lewis wrote a great article about this. So he did a test with 1,300 nodes on the site. And this is the standard layout model. So this took 14.28 milliseconds to load. And then we did it with Flexbox. The size of that layout tree was much smaller and only took 3.5 milliseconds to load. So that is a savings of almost 11 milliseconds, which is pretty significant when it comes to the entire layout of your site. And the layout tree size was 1,200 little nodes smaller with Flexbox. So little fun fact. You can always do a style audit on your page as well to reduce the size of your CSS scripts. So CSSstats.com is an excellent way to do this. It shows you all the fonts that you're using, all the colors that you're using in your style sheets, all the unique font families. There's the specificity graph is kind of crazy over here on this example. And those are all the colors being used. So this is what you want to avoid. What you're sort of striving for is this graph that we see on the right-hand side. And Harry Roberts wrote a great post about ITCSS, which stands for Inverted Triangle CSS. So this is a visual representation of that specificity graph. So how specific you're being with your styles. We don't want to override styles, or we see these really big arcs in our graph. Like the higher it is, you had a really specific style at that point, and then it goes down to become more on the baseline at the next point. This happens when we try to override styles, so we want to avoid this. The area underneath those graphs is pretty much the size of your CSS file. So writing less CSS in a more neat, accurate way, thinking in this inverted triangle manner, gives you a smaller file size for your CSS. So that leads me to front-end development, which is the delivery of your product. It's great if we've made this beautiful cake now. I'm sure it tastes delicious. We didn't mix chocolate and onion powder. But if we can't get it to our customer on time, then what's the point? So we're going to talk about the delivery. And what you can do for delivery is really see that in the network tab. This is your site being delivered to your customer. The ideal for me is this separation of concerns. So this waterfall graph. You have your content layer, your enhancement layer, and your leftovers. So your content is just your essential HTML and CSS, usable non-JavaScript enhanced experience of your site, essentially. Then you have your enhancement layer, which is your JavaScript, geolocation, touch support, your enhanced CSS, not just your critical CSS, web fonts, images, etc. And then the leftovers are analytics, third-party content, advertising, things like that. The way to remember to do this, I like to call CMAT, which stands for concatenate, minify, async, and test. CMAT. So concatenate is when you are pulling together a lot of files. So with images, you can make sprites. With CSS, you can use Sass to pull in all of your partials into one Sass manifest file. With JavaScript, instead of writing them all individually on the page, you can just use some kind of tool. Here's just a task that I use to concatenate all my scripts. There are lots of ways to do this. But the best way to sum it up is a great quote by Steve Souders: "The fastest HTTP request is the one not made." So doing that concatenation of your files will eliminate those HTTP requests. The next step is to minify. And so this is now we've concatenated them. We want to make those files we just concatenated as small as possible. So with images, here's a visualization of using image optim, where you can just drag and drop and watch as those images become minified. CSS looks sort of like this, as does JavaScript once you start minifying your scripts. So this is sort of what we will do to then optimize what people see immediately. And I mentioned this term a little bit earlier, but I'm going to talk about this critical rendering path. And it sort of relates to both scripts and styles. You can think of it in both ways. So the critical rendering path is the intermediate steps between receiving the HTML, CSS, JavaScript bytes and the required processing to turn them into rendered pixels. This is what that user sees immediately. And you can, like I said, do this with both your script files and sort of think about how you're going to be doing this and how your scripts are going to load. So that's what the A is in async. This really stands for async or defer. Just really thinking about it is important. So these are great visualizations of how script loading works. Normally, so the green is all the content on your page. The blue is your script loading, and the red is your script firing. So here we see the content on your page loading, and then it pauses for your scripts to load, and then it continues to be paused until your scripts fire, and then the rest of your content continues to load. That's how a normal script tag works. With async, what happens is your DOM content loads along with your scripts. Your DOM content pauses its loading for your scripts to fire, and then it continues its loading. With deferring, your DOM content is loading, your scripts are loading at the same time, and only when the DOM content is finished loading do your scripts fire. So this is why it's really important to not make JavaScript presentational if you can. It's for the performance benefits of allowing for that waterfall that I mentioned earlier. You don't want any of your scripts to have anything to do with the presentation of what your app looks like visually. So again, with CSS, you can do this. You can, like scripts, load CSS asynchronously. And this allows us to present only the critical CSS, load the rest of our CSS once that critical CSS, so like the above-the-fold content has loaded. And it looks like this. Instead of waiting and waiting for something to hit a point and then appear, we can slowly see it appear on our page. And it makes it feel really fast. So that perceived performance is what we're taking care of. It looks weird at first, and I feel like it seems like it's against best practices, but we are seeing this much more commonly now as we're inlining those critical styles. And there are tools to help with this, like the Penthouse plugin. There's a bookmarklet called Above the Folds, which you can just click on a site. It gives you the CSS of what you sort of see immediately above the folds. You can take that snippet, inline it, and then load the rest of your CSS once the rest of your page is loaded, so that your user doesn't really feel the weight of that page loading. You don't need to render the entire page in 1 second, which is sort of what is recommended here, just the above the fold content. So thinking about this critical rendering path is definitely going to help with the perceived performance and the page load time initially. The last step is to test. And so front-end developers are really focused on the time to render, time to display, and the time to interact with your product. So here we go. There's so many testing tools. But Chrome DevTools, just inside your browser, is an excellent one. The network panel we sort of saw earlier as I talked about the waterfall charts. There's the audits panel that actually gives you recommendations specific to the project that you have open right then and there in your browser. If that's not enough for you, there's pagespeedtest.org, which is separate, and it gives you grades on things. It also shows you waterfall charts. There are a lot of benefits to using the site. It gives you a bit more depth into how your page is rendering, and you can also affect your network speed, so you can test it on different networks and devices. And it gives you this thing called a Pagespeed index, which is some hippie math that tells you how fast it feels to load your website. But this number is really important, and it's right here on the page. A good number to go for is to be below 1,000. That's how you know you're like in the cool kids club, if your site's below 1,000. It also gives you these like videos, and you can see visually how long it takes for your page to load and what your user is seeing at that time. So it took up to about, I think it's like 3 or 4 seconds to see anything on the page at all. So that's not good. But then at 11.9 seconds, all the scripts and everything are finished loading. That's when it turns gray. So you can really analyze just millisecond by millisecond how your site is loading and how it feels and looks to your users. There are a lot of other details that you can sort of dive into. It gives you specific recommendations. One of those recommendations is to use progressive JPEGs, for instance, and make all these changes to get really great grades. Sort of a fun challenge, like gamification of performance. Then there's also the Google Pagespeed Insights, which gives you a score out of 100. It sort of does a lot of those same things that you see in that audits panel. And they have different sort of examples for mobile and as well as desktop. And they look for specific things, like are the icons big enough? Are they far enough apart? So even just the UI of your site, it's testing that for usability and performance. So here's the desktop view. There's also an extension that you can download to just use within your browser, and it is in Google Analytics. They really want you to focus on performance and care about this, as you should. You can automate your performance testing, though, if you don't want to manually go through these every single time. And you can do that with task runners. Any of these, so Grunt, Gulp, Broccoli, there's so many. I tend to use Gulp. Some of the examples I showed were in Gulp. So here's an example of using the Pagespeed Insights Gulp plugin. So you can input the site that you're using. It will require this plugin. If it's a default Gulp task, you just write Gulp. And then inside your terminal, you see your score, you see the strategy, and you can get a few different numbers and information. So you don't even have to open a website. You don't have to open your browser. You could see what it looks like just inside of your terminal. And this works for sites that are hosted. But if you want to test locally, what you can do is set up a tunnel with ngrok, and then use that tunnel to sort of port inside of the Gulp setup and get your local host pretty much put on a tunnel so you can test it. And the last thing you might want to do is set up a performance budget. So this is kind of what we did over at Bluemix. We looked at our competitors, and typically you want to be 20% faster than your competitors to honestly be perceived as faster. So if it takes your competitors' sites 5 seconds to load, you want yours to load in 1 second because you want it to be perceived as faster. So you want it to be loaded in 1 second faster, so 4 seconds. God, 1 second would be great, though. And if your site is faster, it will convert users. So let's review. We're all in this together. It takes your whole team. As development leads, you need to make sure that designers are thinking about performance as they're building from the start, so you're not coming to them later and saying, oh, we need all these assets recreated. Hold on a second. And here is a good checklist. So determining your important content, creating those performant images, and then taking those images and optimizing them. Using dry style sheet architecture, so thinking about ITCSS, not repeating your styles. That will create for smaller style sheets. And then considering your critical rendering path with both your JavaScript and styles, concatenating your files, minifying those files, async or deferring your script loading, just thinking about how you're inputting those scripts, and then testing, repeating and iterating. Another great feature is this little tool that you can test for mobile. And it allows you to sort of check your device, and also you can throttle your network. So that's a really cool thing you can do just in your browser. It's just like a little mobile icon, and I use it all the time. But it doesn't replace the real thing. So I know that I've shot myself in the foot with this before, where I had fonts that I thought I had put up, but they were local fonts, and you wouldn't know that if you didn't test it on someone else's device. So it was like 3 months I didn't realize I wasn't sending the fonts I wanted to on like my personal blog. I was like, oh, now I see why. Now I see why. So yes, there are all these great testing tools, but having a device lab is also fantastic. So I hope that this really fast overview of performance in general helped. I tried to speak fast because there was so much content. I'm so sorry if you didn't catch some of it. But here's some links, and I'll throw this up if you want to access any of them. Or you can tweet at me. It's just at UNA. Or find me, and I would be happy to chat with any of you. So thank you.